Okay, so I've written down some more formulas here. Now, all I've done is I've used Pythagorean theorem, but I just introduced our new units. So VA equals P squared plus VAR squared square root it. That'll give you your VA. If we're working the other way, and we will find our VARs. So VARs will equal VA squared minus P squared square root it. So again, we've used this formula multiple times. I'm just showing it written with the new units we'll be using. Power factor. So what is power factor? So again, I'm a large industrial factory business of sort, and I'm paying for hydro. Now I have many motors, presses, maybe there's injection molding, lots of inductive loads. I'm going to have probably a poor power factor if I don't correct it with capacitors. Again, we'll get to that later. So I haven't corrected it. I'm wasting a lot of power. Okay, so my VA is much greater than my power, and there's going to be a percentage that I'm wasting. So maybe I'm 75% efficient. So 25% of the power I'm paying for, I'm not actually utilizing, and that's bad. Hydro says we're going to ding you for that. We're going to charge you extra costs because your power factor is below 90%. So anything less than 90%, you're going to start to pay additional costs associated with the waste that you're using. So factories, you're talking about your largest factories, your Toyotas, your Linamars, they want to have a power factor of at least 90% efficient. So they're definitely going to have capacitors involved to correct their power factor. That way, they're not paying further costs because of how bad they're utilizing their power. So these factories, they want to know what their power factor is. So it's as simple as take your power, your watts, and divide it by your VA. Now, if we want to find out our phase angle or our angle between the two, again, we're going to do what we've been doing to this point, tan invert it, VARs over P, or the vertical over the horizontal. That formula hasn't changed. And again, opposite over adjacent, if we want to call it that way. Now, let's say we have the angle, but we don't have our VA power VARs. We can simply just, we're going to call our angle X. So angle X, is X, whatever. So power factor equals the cos of that angle, and that'll give us a decimal number, and we can do times 100, and then I'll put it into percentage. If that percentage is less than 90%, we're going to be looking at installing a capacitor and sizing it. That'll be further down the road. So here's a few more formulas for you. Again, you can see the relationship with the formulas to the triangle. Triangle helps us to visually see the circuit. Now what I'm going to do is I'm going to make up a circuit, put it on the board, and show you how it all comes together.